keep that in mind. The fact she has an elongated anestrus period also is going to play in this a little bit as well. So what I want to do is work our way through here. I've added some notes to this that was not in this diagram in your book. The little things in proestrus and the little gray boxes are added to movement. We'll talk about some things that are unique as we roll through this, but we want to highlight these different hormones, the levels, and what's going on. So let's take a look and start in anestrus, and you'll notice we've got the same hormones we've talked about. What, though, was the FSH levels previously during times of non-cyclicity? What would we typically expect FSH levels when an animal is in anestrus? Again, we've established these rules, and we're going to break some of them. So when we talk about anestrus, what do we typically think about relative to levels of hormones?
They're preparing for cyclicity.
Well, what do we think about? When I say anestrus previously, we're talking about lactational anestrus or pregnancy anestrus, or seasonal anestrus. What do we talk about hormone levels during the anestrus period? Are they high? Are they low?
High.
Sure? They're low, right? Because why? It's an anestrus period. They're not cyclical during anestrus, so you would not expect any hormones to be very high. Here's the first rule that's broken. During anestrus, in the bitch, FSH level stays relatively high throughout. Now you ask yourself the question, why is that? There's a couple reasons. One is the fact that she is a litter bearer, so she has more work to do relative to stimulating follicular growth. But because this is such a long period of time, she has to keep the hormone level fairly high, otherwise she potentially would lose follicles. If the hormone levels drop too low, you'd have follicular death. So in order to keep follicles active and alive during this long anestrus period, her FSH levels are relatively high. Now, you'll notice when we follow FSH, it stays relatively high. And keep in mind, this 5 month, again, they shortened your diagram a little bit. It's 5 months, obviously, we extend way out here compared to these others. But FSH levels stay relatively high and relatively steady throughout anestrus. What's happening, though, as we approach the end of anestrus relative to FSH levels and the follicular pool? What do we call that process? What has to happen to the follicular pool? The ultimate follicular pool is going to be ovulated. What has to happen to them first? We've already talked about it. What do we call that process? It's a twofold process. Recruitment, and then what happens after recruitment? Selection. Okay. In this area here, with this FSH that's relatively high, is where we have recruitment of the follicular pool. So that plays into it a little bit as well. You'll notice FSH levels drop off. So what happens to follicular growth at that point right there? It basically stops. So we've recruited the pool of follicles that she's going to ovulate. Now they stop growing, and they're waiting, or at least some of them are waiting, for another shot of FSH to stimulate the selection process. Okay? So we should expect, as we saw in other animals, we should expect a rise in FSH sometime down the line. We will. What hormone is going to cause this drop in FSH? Inhibin, okay, just like it was in the other animals. So this drop is associated with inhibin, causes an inhibition of FSH. But again, the recruitment of the follicles has ended right there. They're just now sitting there waiting for a high level of FSH to stimulate the selection of the ones in that recruited pool to actually ovulate. So we should expect, again, FSH levels to go up, and we do see that. We'll come back to that in just a minute. Now this estrogen level here, this is not necessarily a high level of estrogen, but it is a relative to what we'd expect in anestrus is pretty high. We don't expect rising levels of estrogen. All this is basically a pump primer. This just keeps GnRH being produced to maintain the FSH levels at a steady state high level during anestrus, because estrogen, of course, has a positive effect on the hypothalamus. So that's all that is. That is just there to keep FSH levels high. That's just a stimulatory thing. All right, now let's talk about all this other stuff going on relative to proestrus, estrus, and diesters. Now, proestrus, of course, is where we would expect to start to see changes in follicular development as well as potentially early changes in behavior. We'll see in proestrus an increasing level of estrogen, as we would kind of expect. And one thing that is a little different, and this is average. This is not for every single bitch that's out there. Certainly, some bitches would have potentially this estrogen threshold level higher, further in estrus. This just kind of shows an average here. So we see a high level of estrogen here. So what should we expect around this area from a behavioral standpoint? We have high estrogen levels. We have what? We should start to see some sexual receptivity relative to this estrogen. So the same kind of stuff we've already seen. I will point out a couple of things from more of a visual indicators that differ between proestrus and estrus in the bitch, some things we can observe if we have an intact bitch or we breed dogs or whatever. If we start to see kind of a bloody, not dark blood, but a little bit of blood streak discharge from the vulva, that would indicate that this bitch is in proestrus, not estrus, because the color of that discharge will change as an indicator of what phase of the estrus cycle she's in. We also start to see the swelling of the vulva, but it tends to be hard. That swelling will continue, but what will happen as we get into estrus is it will soften some. Turgid means hard. Okay? So that's all that means. So a couple indicators there. And of course, a lot of that is controlled, obviously, by estrogen as well. Now, what should we expect to see relative to FSH levels? As we approach estrus, in this case, we start to see a rise in FSH. What is that rising FSH doing? What's it doing? Go back to this one. What will happen right there? That was the end of what? That was the end of selection. Selection is the potential follicles have been selected. FSH levels go down in response to inhibin. Now FSH levels are going up. What's that doing?
Picking one.
That is stimulating. Nope. Did I say that back? I think I just said that back.
Yeah.
That's the end of what? Recruitment. I think did I say selection?
Yeah.
Recruitment. Okay. Right here. After we recruited this pool of follicles, then what do we need to do? We need to select the ones out of the pool that we're going to ovulate. That's what that rising level of FSH does, is causes selection of the follicular pool that's going to be ovulated. At the same time, of course, and this is similar to what we saw in other animals, we see in response to this threshold level of estrogen, we see a surge in LH. It's kind of hidden there, but we see a surge in LH fairly early in estrogen, and obviously after that we would see ovulation. Now, one thing that is a little bit interesting relative to the bitch is the length of the estrus cycle, and this causes a bit of a challenge. The length of the estrus cycle on average in the bitch is about 9 days, so it's very long. How much of that time is she receptive to a male? All 9 days? Probably not. Most of the 9 days? Certainly potential. Okay? So you've got to keep that in mind, the fact that she has an elongated period of sexual receptivity, and if she's receptive, that means that she is truly in estrus, or in proestrus. If she allows a male to mate with her, she is in estrus at that point. Okay? A few signs relative to that, of course, the color of that discharge changes from a blood kind of streak discharge to more of a honey-colored, straw-colored discharge. That's a good indication that the bitch is in estrus. Behavioral responses relative to her receptivity. If she allows a male to mate with her or mount her, she's in estrus. If she does not, she's clearly not in estrus and likely in proestrus. Now, what about this issue here, though? And they do a good job of showing you kind of and this is not going to be true of every bitch, but again, on average, 3 days into estrus is roughly when ovulation is going to end. So when does it start? Well, I don't know. Depends on the bitch. But when will we suspect it to start?
Between proestrus and estrus.
Maybe. But what's my clear indication of when ovulation should start? Or at least surely gives me a close indication of when ovulation starts. The surge in LH, right? Because if we surge LH right there, say it's right on that line, when should we expect ovulation to start? Sometime shortly after that. So let's just take, for purpose of discussion, say on day 1 of estrus, this particular bitch, ovulation starts. So the surge in LH took place about day 0. Day 1, ovulation started. When is ovulation stopping? Day 3. So how many days did she ovulate? 2 days. That's a long time. 2 days of ovulation is a long time. What does that mean? She is kind of pumping out ova. Okay? What does that mean? Okay, she's pumping out ova at the same time over an extended period of time, a couple of days in this example. She's also receptive during that time. So what's our potential here? And this is an issue particularly when you raise dogs. What's the issue?
Having 2 different fathers.
If you've got a bitch that is receptive over several days, in addition to the fact that she has, in this case, a couple of days where she's ovulating over a couple of days, is she only going to be bred by one male in that time? And that's it? Well, maybe. If you breed dogs and you have a bitch that is in estrus, and you have total control over that bitch, and you introduce that bitch to this dog, and you see the mating, and you never again take your eyes off of that bitch until she's out of estrus, are you assured of just him mating with her? Probably. However, what's the challenge if you have a bitch in estrus? Anybody have an intact bitch in here? If you have a bitch that's in estrus, are they fun to be around? No, what do? They're noisy and they go crazy, basically. If you have them confined, what do they want to do?
Get out.
They want to get out. Why do they want to get out? Because they are, well, I shouldn't say that. They're little bitches, okay? What are they trying to do? When they get out or want to get out, what are they trying to do? Find a male. They're trying to find a male. So I always use this funny analogy, that's a good way to think about it. Okay, so beagles are my favorite. Let's go with beagles. This is my favorite breed, right? So I'm a beagle breeder. I have the best beagles on the planet. Okay? All right, at least I think I do. I got a really good bitch right here that she is ready to be bred. She's in estrus. I'm ready. I'm going to take her to that dog, this champion dog here, and they're going to do their thing. I've watched it. I even recorded it. I wrote it down. I did everything I needed to do, and I took that bitch back and put her in her kennel, and I said, okay, you're done. But she's not done. What does she do? Well, at night, she gets a little frisky, and she climbs over her contained area, or she digs out, or she literally, with her teeth, rips it open. That's how bad it can get sometimes with a bitch in heat. And she gets out, and she goes next door to the guy next door. And he's got a Chihuahua.
Oh.
And she likes that Chihuahua. She does whatever it takes to make it happen between her and that Chihuahua. She accommodates, okay? Let's put it that way. But I don't know that. I'm asleep. And what's she do? She does her thing next door, and she comes back, and she gets back in her contained area, and goes back to sleep or whatever. And I wake up the next morning and say, hi, dear. And so 2 months later, what do I find?
Chihuahua beagles.
I find a litter of odd-looking puppies. I probably have some beagles in that litter, right?
Mm-hmm.
That's a good thing. But I probably have these other weird-looking things in the litter. That's probably a bad thing. Because why is that a bad thing? If I'm breeding beagles, why are these little ones a bad thing?
Because they're not your product.
Yeah, they're not purebred. They're taking away from other potential purebred puppies I could have. Right? Why did that happen? She was ovulating over a long period of time, relatively speaking, and she was still receptive, so she was bred by more than one male. And in that litter, there are more than one sire represented. You know what that term is called? Super Superfecundity. Okay. Superfecundity is the term where more than one sire is represented in a litter. Could there be 3 sires represented in a litter? Could there be 4? Yeah, I mean, technically it could. If you had I don't know, let me just say it nicely, a non-controlled bitch in heat. Meaning she can do what you want to. Few wrongs. What's she going to do? Well, tonight, she might be bred by a couple different males. Tomorrow night, she might bred a couple more. So there's, a lot of potential for a lot of different males being represented in a litter. And the reason that is because we have an extended ovulation window at the same time the bitch is receptive to the male.
This might be kind of a silly question, but how far away can a male be and realize that there's a dog in heat somewhere?
That is a good question. I don't know an exact answer to that question, but let me just answer it a long way. Because what it is, she brings up a good thing. We know what pheromones are, right? Mm-hmm. Those olfactory. A bitch, her urine particularly, even those vaginal discharges have lots and lots of pheromones in them. And of course, she's wandering around, even in her own area, and she's urinating and vaginal discharge, whatever. But that wasp in the air, they're strong. So it can be a long way. Exact number, I have no idea.
My grandmother had a Labrador that was outside for most of the time, and she wasn't fixed, and we thought that she got possibly bred by a coyote. And it was, really, really weird. But there was 3 houses down that were always near when she was in heat.
I'd probably go with that one. I don't know if there's interspecies, and I don't know, there might be. I'm not sure about interspecies with coyotes or not. There's interspecies. I'm not sure if that's
but I don't know.
I'm not sure if that works.
I don't know if I was a little kid. I didn't really understand what was going on, why there was all these dogs in our front yard, or in her front yard. And she wouldn't explain it. So.
That's the thing about it. Pheromones in the bitch, the pheromones are there really to attract the male to her. But at the same time, her desire, her brain goes crazy. Her desire, because of her high estrogen levels, to find a male.
Yeah, she always got out.
Yeah, so it's like you got 2 things clashing at the same time, and if you got an intact bitch, or even an intact male with a bitch in the area, that's in estrus. That's tough. They'll do a lot just to get out to try to get to the bitch too. So yeah. But this whole concept, and it's a challenge if you have an intact bitch, is because of this long estrus period, as well as within that this long period of ovulation. Yeah.
My pug is not spayed, but she doesn't act like that at all when she's in heat. She doesn't. You wouldn't
Really?
even know it if you didn't.
Really?
Seriously. I wanted to breed her, but she wouldn't. Nothing.
That is interesting. I wonder if she has like a naturally or even genetically controlled low estrogen level.
Well, the first time I wanted to breed her, we did the vaginal swabbing and stuff, and watched the follicles, but never could catch it. So then the second time she came in heat, we actually did the actual ovulation where you get the blood.
Yeah.
But still couldn't. So we actually, she was AI, but never could catch it.
That's interesting.
I think she was one that ovulates at the very beginning versus towards the end.
Yeah.
But yeah, you would never know if you didn't see the blood.
That would be tough if you're you're using her for a breeding program. That'd be hard.
She doesn't act like it at all.
I don't know if that's a good thing or a bad thing. It might be a good thing.
I mean, I don't care to breed her, so it doesn't bug me. But
Yeah.
I don't know. You were talking about this.
At least she doesn't. At least she's not. I guess you can take solace in the fact she's not crazy like some of them as far
Yeah,
as
she just
when they're.
sleeps.
Really?
Yeah.
That's weird.
All
Yes,
four
ma'am.
days, kind of like
An animal that is fixed still gonna have those hormone fluctuations and different behaviors kind of still synchronized.
Yeah. Yeah. It's not. It's not as predictable. But I mean, I've got. You say the reason why I agree with you. Yeah, you can see that I've got a spayed bitch that I won't say she exhibits sign of being an estrus, but she certainly from time to time exhibits signs of higher estrogen levels you'd expect. So, they compensate, but they're never going to be at the same level. But it's not synchronous and just but you can see some of it, yeah. And honestly, in the bitch and a dog, you see the same thing. So does that all make sense relative to that concept and this concept? Okay. Now, this also shows, and again, this is just kind of an indicator, is when fertilization will be complete. Now, that's assuming mating took place. Of course, if you've got an elongated period of ovulation, as indicated there, you would expect fertilization, once mating takes place, is going to be also extended. So this kind of gives you an indication where fertilization might, and again, this is just rule of thumb. This could vary between how many times she's mated or the particular individual. Now, this term of capacitation, don't worry about that too much right now. We will come back to the physiology of that. Capacitation, all that means is for the sperm cells to actually become fertile, they have to react to the female's tract. And we'll talk about all that a little bit later. That's all that means. But that would take place, obviously, in this window. Now, another thing that's weird, and we'll see this in the queen as well, is this whole concept of diestrus versus pregnancy. We would expect, of course, after ovulation, CLs to form. And if CLs form, we're going to have what take place relative to progesterone levels. Go up, right? We know that. And we know that's an indication of diestrus. Here's the tricky thing. What's the length, and again, average numbers, but what is the length of diestrus in the bitch? 2 months. What's the length of pregnancy in the bitch? 2 months. So how does that cause a challenge? If a bitch's diestrus is 2 months and her pregnancy is 2 months, how do we tell the difference? You're like, well, you could ultrasound. Well, yeah, of course we could ultrasound. But if we don't go to that extent, how do we tell the difference? Sometimes we can, and sometimes we see what's called false pregnancies. Because during pregnancy, if this were pregnancy, if we just mark through diestrus and put pregnancy there, would any of this change? Would that level of progesterone change? No. If we take that away and put diestrus, that level of progesterone change? No. So one can be masked by the other. So we can see false pregnancies where the female thinks because of the progesterone level she is pregnant, but in fact she's not. Of course, we have a lot of technology out there that would indicate that a female would be pregnant or not, obviously. But if we didn't use that, we can certainly see that. And that's only because the length of diestrus in pregnancy are roughly about the same length of time. So for the most part, diestrus, other than its length compared to pregnancy, it follows the same rules we've seen with other diestrus periods in other species. Does that all make sense? Any questions on that? Where things, again, a lot of it is the same, but there's a few things that do break our rules relative to the bitch.
Well, it's not kind of like the same thing, but I mean, can a spayed female take on like maternal behaviors, even if she's never had?
Yeah. Yeah, and I don't know, that probably is related to, it's related to her prolactin levels. She still produces some prolactin, but yeah, certainly she can. Yeah, I've seen that before.
Like different, like species, can she also have maternal behavior to it too?
Anecdotally, I've seen that. Now, I've never seen that in person where, you've got a bitch, a spayed bitch that, she fosters some ducks or something. I've seen that. As far as how prevalent that is, I don't know. But they certainly can show maternal. Yeah. Yeah, that's what you typically see is dog, cat, or sometimes cat, dog, but more dog, cat kind of maternal behavior, yeah. And that's all prolactin effects.
I've had a cat nurse a baby mouse. She put a baby mouse in with her newborn kittens and nursed it.
Oh, I was going to say, how about newborn kittens? Okay, that makes a little bit more sense.
And then the kittens, I think, eventually, didn't share it all.
Yeah. Well, it's like, that's the thing. Prolactin is such a strong hormone on the brain that they,
She saw any baby and was like, okay.
Yeah, exactly. So that's about the way it is. Yeah. You see, and so of course some species they want to kill. Even if it's the same species, they want to kill another baby that's not their own. So it does vary a little bit. Okay, let's talk about the queen. The queen is interesting from the standpoint of she is an induced ovulator. Now, what does that mean? What does induced ovulation mean? Yes, she's got to be stimulated to ovulate. That's not true of other species. They're spontaneous ovulators. In the case of the bitch, and there are other species, the doe rabbit is also an induced ovulator. They work a little bit different than this, obviously, but induced ovulators, they must be induced. That means there must be some sort of tactile stimulation, typically on the cervix and the vagina or the vaginal walls, to stimulate a surge in LH to bring about ovulation. Now, how that tactile stimulation takes place, it varies. What do we know about the TOM relative to this whole concept of induced ovulation? We saw those penile spines on there. How many times does a TOM typically mate a queen? How many times? Once. Have you ever experienced the mating of cats? You may have heard it before.
Yeah.
Outside the window, screaming, and it's very violent. I mean, I don't know if it's violent because of the penile spines. I don't know what, but there's a lot of grabbing of, skin and scratching and all that, and running real fast when it's done one time. Because those penile spines are so effective at that stimulation, that's all it takes. Have you ever seen rabbits mate? Rabbit penis does not have, a buck's penis does not have spines on it. It is fairly long relative to his body size, but how do they typically mate, both in captivity and in the wild? It's a natural thing. They're induced ovulators, but they don't have penile spines. They typically will mate multiple times with one another, and that actually increases the stimulation of his penis on the vaginal walls and on the cervix. But again, he doesn't have spines, but it's more of the amount or the number of times of copulation in the case of that type of induced ovulation. So a little bit of the difference there. Now, what you've got here, I want you to concentrate on three things. Two are on the slide, one I'm going to add to it. Because they're, and you always have to keep it within the framework of they are induced ovulators. They are induced ovulators. I want you to tell me what phases of the estrous cycle we would experience in a queen that is, assuming she's intact, obviously, never mated. What periods of estrous cycle is she's never mated? Okay, that's one. Periods of estrous cycle is she's mated to a fertile TOM. To be on the right side of that. And added to this, what happens if she is mated to an infertile TOM? What phase of the estrous cycle do you have? So let's define a few things first on this slide. This is a little bit different relative to the other slides we've seen. Where's my eraser? Each one of those, now this is very generic on this diagram. Each one of those high levels of estrogen would indicate what to you? What's those high levels of estrogen indicate? Receptivity, right? So between that estrogen there and that estrogen there and that estrogen, what do we call that? That length of time. The estrous cycle. So she has an estrous cycle too. It's a little different as far as phases go. So each one, so that's estrous cycle from there to there and there to there and there to there and there to there. Okay, so that's the estrous cycle. How long roughly is the estrous cycle in the queens? Anybody know? About 28 days. About 28 days. So roughly about every one of these is 28 days in between. Now, here's the key though, is this whole induction of ovulation thing. Do queens have a proestrus? Yes, they always have a proestrus. So we always start with P. Okay, we always start with proestrus. It's not indicated on there. You could draw it on there if it helps you. But right before this high level of estrogen, you would have proestrus. What would be the phase represented by the high level of estrogen? Estrus. Okay. Now again, we're working on the left side, meaning she's never mated with. What is then going to occur after estrus if she's never mated? Because if she's never mated, what's going to happen? She's not going to ovulate. If we have no ovulation, we have no CLs. If we have no CLs, we have no high level of progesterone that defines diestrus. So what do we have relative to a queen that is never mated? We have a unique phase called interestrus, and that's the phase in between here. Now your book, and I actually put that over the term in your book. Your book, I believe, uses post-estrus. I don't care which one you use. I just think this makes more sense. In between estrus. Okay? But this is interestrus phase here. Interestrus phase doesn't exist if she is actually mated with. Okay? That's only if she's not mated. So in a queen that is never mated, you've got you've got. I just totally. Okay. I need spring break again. What's the P? Proestrus. Duh. Proestrus, estrus, interestrus. And then what happens after that? Starts over again. Proestrus, estrus, interestrus. What happens like that. Same thing. So, how many of you have an intact queen? Does anybody own an intact queen? No, you notice not very many hands went up. One did. How many of you own a queen? More hands. Why do you not own an intact queen? You think a bitch is a bitch? An intact queen is a real bitch. Why? Because every month she's going to exhibit crazy wild things, okay, crazy wild signs, because she's an estrus, so it's more frequent. So that typically is why we spay queens. So this is a queen never mated. Now what about mating? That's the induction part. What's the phases? Do we have a proestrus? Yes. Do we have an estrus? Yes. What about after it? So we've got a proestrus, we've got an estrus. What about after that? Ooh, this gets tricky. What about after?
Ovulation.
You've got ovulation and then pregnancy, assuming fertilization, right? Because what has happened if it's been mated? Mating there. If you mate, that means you induced ovulation. If you induced ovulation, that means you make CLs after ovulation, which means your progesterone levels are going to go up. But what do we call that period if fertilization took place? Pregnancy.
So it's
Proestrus, estrus, and pregnancy.
not ovulation.
Well, you could put ovulation in there. Ovulation wouldn't technically be a phase of an estrus cycle per se. Neither is pregnancy for that matter. Now, I will talk about this and then we'll come back to the mating of the infertile male because that one becomes a little bit interesting. So notice pregnancy in the queen is how long? Oh, we've seen this before. It's about 2 months as well. Okay, we'll see that in a minute when we get into this whole false pregnancy thing again. So this would be pregnancy, high levels of progesterone. You already know that. Now, what is this period right here? Notice they're helping you out. Lactation is taking place here. What is that period called right there? Lactational and estrus. That is not a complete lactational and estrus. Why not? Because cyclicity is started back before she finishes lactation. But you'll notice there's an anestrus period there early on. That is a partial lactational anestrus. If there's a full lactational anestrus like south, there would be no cyclicity as long as lactation is taking place. Now, here's the ones you don't have a slide for. What happens if and this certainly can happen, what happens if a queen is mated by an infertile male? What's your phases? You always start with proestrus. Estrus. Got to get receptivity. So, mated with an infertile male. Okay. She said, you still have ovulation.
And you can have false pregnancy.
You have no sperm cells, though, right? So you had ovulation, no fertilization.
Right.
Diestrus, very good. You have diestrus, so you've got proestrus, estrus, and diestrus. But guess what? Diestrus and pregnancy are the same length in the queen as well. So you can also see some false pregnancy things relative to that. So you might have if you breed cats, say, you know, maybe you'll breed cats, say you do, you've got a really good queen and a really good tom, and the tom has to be infertile. You don't know it. There's the potential you mate them, and she acts pregnant, but she's actually not because she's in a false pregnancy phase because, again, the length of her pregnancy. And diestrus, in the case of mating to an infertile male, would be the same. Does that make sense, how those work? It's all about induction of ovulation in the queen, so it throws a little kink in the works relative to that.
So you said that was partial lactational anestrus?
Yes. And the reason being, notice you still have the lactation arrow there, but what's happening here? Her first estrus. So she's lactating, but also giving the estrus at the same time. That's why it's partial and not full lactation. Any other questions on that? Okay. One more slide, we'll be done with this, and then we'll jump into sperm structure a little bit. Okay, all this, nothing fancy here. You've seen all this stuff before. All this is indicating is this induction pathway. You'll notice you've got receptors in the case of those animals that are induced ovulators. The cervical wall and the vaginal wall, you've got tactile receptors there, so stimulation of those receptors by way of the penis typically. Can you do this artificially? Can you artificially induce a queen or a doe rabbit?
Yeah.
You can? Yeah, you can. I mean, you can do it with something as simple as a Q-tip. That simple can induce it. So there's actually some work in rabbits on doing that. It's not nearly successful, but it does work. So tactile stimulation sends a signal basically through the spinal cord, ultimately leading to, as you already know, the surge center causes surge in GnRH, which causes surge in LH, which ultimately leads to ovulation. So it's pretty simple. It's a pretty simple neural network. Tactile stimulation at the cervical level, at the vaginal level, is going to ultimately cause a surge in GnRH after that, because it's a direct effect on the thalamus cyclic nuclei causing surge in GnRH from surge center, and then a subsequent surge of LH. So it's all pretty straightforward stuff. Okay, any questions at all? Ester cycle questions? I know it's been a while since we talked about it, but anything at all? Okay. Let's see how far we go with it. I want to do something funny. I think it's funny. I don't know. Maybe I'm just tired of standing up here and telling you talking all the time, so I'll let you do the work. Not that scared. All right, let's talk about sperm structure. We'll talk a little bit about sperm anatomy here. Now, I want you to think about a sperm as what? What is a sperm? You thought about that? Don't overcomplicate it. What is a sperm? Yeah, okay, it's a gamete, I agree. It's a cell, right? It's a cell. You know about cells. What are some parts? Don't worry about sperm right now. What are some parts to a cell? We talked about it last time. I know I freaked some of you out. Go back to your biology class. The big sphere. You know, what's some parts of cells?
Nucleus.
Oh, are we going to have a nucleus and a sperm?
Yeah.
Yeah. Okay.
Chromosomes with DNA.
Okay. That would be the nucleus, right? What else? Other parts?
Lysosome.
Okay. Lysosomes. Now that doesn't play in effect as much with the sperm cells. We already talked about that relative granulosa cells. Good. Mitochondria, powerhouse, right? ATP generation. What else? You know that? Golgi, my favorite Golgi bodies. We'll talk about Golgi bodies later on, not today. Centrioles. Heard that term? Okay. In play here. Everything we will talk about relative to a sperm cell comes from the fact it is a cell. It starts out as a basic body cell. It looks just like a body cell. But obviously it's going to be transformed into what? This weird thing that is able to transport genetic material and deposit that genetic material at the site of fertilization. That's its job. So everything we're going to build as we make a sperm cell is about getting genetic material to the site of fertilization. Okay, how are we going to achieve that? What does a sperm need to do that? Well, it needs a nucleus. That's where the genetic material is. That's pretty easy. What else does it need? What's the most obvious thing a sperm cell needs? It needs a tail. It's got to have something to wag the dog, okay, as it's getting where it needs to go. So the tail is going to be important. What does it need to wag that tail? It needs ATP. Where are we going to get ATP? Well, maybe mitochondria. Okay. How do we form the structure of that tail? Well, same kind of stuff that we form a microtubule structure of any cell. We'll talk about that. Does it need enzymes? Why does it need enzymes? Because it has this kind of dig through thing during fertilization, which we'll talk about. Okay. So let's talk about some of the basic parts of a sperm, and we'll look at some diagrams. Okay, so the sperm contains a head. Now the bulk of the head is what? The nucleus. Okay, that's where the genetic material is at. That's the bulk of the head. It has a midpiece, which typically is the area that we would associate with the mitochondrial sheath, which is the location of the mitochondria. The main piece, which is the longest piece of the tail, or the portion of the tail, and then the end piece, which is the very, very tip of the tail. Those are the basic segregations of a sperm cell. Now, what we talk about in here is going to be primarily focused on mammalian sperm. What you see today is a bull sperm, but it looks just the same in any mammal, basically. Avians are quite different relative to these parts pieces. Does a cell have a plasma membrane? If I take a cell out of my skin and look at it under a microscope, am I going to see a plasma membrane? Yes, of course. Does a sperm cell have a plasma membrane? Yes, it's a cell. Yes, it has a plasma membrane. What's the acrosome? What's the acrosome? Now we're going to see how the acrosome forms. Hint, hint, my favorite organelle makes it, Golgi body. Okay? Me and the Golgi are very close. I love the Golgi. I just like saying Golgi. As you can probably tell. Okay. What does the acrosome do in the sperm cell? Anybody know? It's this bag of enzymes on its head. And eventually those enzymes are going to break out when it needs to get through things. Okay? You know that I always use this example. People think I'm saying, I swear one day we'll buy one just for this purpose. But y'all would all make more fun of me than you already do, right? If I know you all own one. The little toboggans with the little thing hanging down things. You know what I'm talking about? You know what I'm talking about?
Yeah.
Now, I mean, none of you do it, but you put this thing on your head, you're supposed to tie it, right? That's the strings are there for that purpose. Do you realize that? None of you do that, right? Of course not. You look like idiots. But if we did tie those little stringy things and anchored them to our head, that's basically what the acrosome is. It's like putting this cap on your head and tying it down. The tying down part is a different structure of the sperm cell, which we'll talk about. Talk about the nucleus, obviously. What's the number here? Chromosome number? Not the exact, depends on the species, but what's, you don't know this. No, not the exact number. I don't care about the exact number. It's haploid. What does haploid mean? Half. Why do we only have half? You're going to meet up with other in the ovum to restore the diploid state, right? Mitochondrial sheath, which is a modification of mitochondria. That's the powerhouse, which we get ATP for the wagging of the tail. And then the tail itself is the longest, obviously, portion of the sperm cell, which includes the midpiece, the main piece, and the end piece. Okay, so let's look at a diagram. I don't remember if this is out of your book or not. Your book probably got something. I like the diagram. Even though it may not be easy to see where you're at. I'm going to do a little example of this in a minute. It shows you the microtubule structure. I think I'm going to send. But let's look at the structures. Here's the head. Here's the midpiece, which again is primarily composed of the mitochondrial sheath. And then here's the main piece, which is the longest part of the tail, and the end piece is the very, very tip of the tail. So the head is, if we turn, we're looking down on top of this sperm cell at this point. If we turn it on its side, so you're looking like this, if we turn it on its side like this, it actually is flat, and that would be it turned on its side. So let's look at some of these parts. There's a plasma membrane that surrounds the entirety of the sperm cell. Now we're going to talk later on about how this actually forms this structure like this. But today I just want to do the anatomy stuff. So we've got a plasma membrane that surrounds the entirety of the sperm cell. We've got the acrosome, which is this cap here that surrounds the top half of the head. That contains acrosomal enzymes that are going to be used during fertilization to get into the ovum, which we'll talk about. We've got this structure called the postnuclear cap. That's the little strings of the little toboggan. That's what anchors the acrosome down to the sperm's head. Otherwise, it'll come off. Can an acrosome come off of a sperm's head? Can an acrosome come off of a sperm's head? Yeah, it can. Is that sperm any good anymore? Why is the sperm no good? If he doesn't have that bag of enzymes, he can never get into an ovum to fertilize. What if a sperm has no tail?
Can't go anywhere.
It's no good, right? It can't move. What if he has a malformation of the tail? Same deal, right? If he has a malformation of the head, same deal. So lots of things can happen. So you've got the postnuclear cap that ties it down. Now I want to point out a couple of things. And I realize this is not up close, so it's hard to see. We'll look at some more up close probably next time. The centrioles. You'll notice a proximal centriole and a distal centriole. I will argue with this diagram a little bit. During the formation of the tail, the proximal and distal centrioles are close to each other. They're not as far away as it indicates here. Proximal referring to towards the head, distal away from the head. Centrioles in a cell, in any cell, it creates a microtubule structure to give a cell rigidity. Make it, an animal cell even. Give it rigidity. Well, guess what the centrioles do in the case of a sperm cell? They make the bulk of the tail, specifically the microtubule structure of the tail. The proximal centriole makes the quote-unquote head of the tail, because the tail is going to come loose from the head right at that point right there. So all the stuff, and we'll talk about that in just a minute, or probably next time, all the components of this attachment area of the tail to the head is formed by the proximal centriole. The tail microtubule structure that runs from that attachment point all the way to the end, that is formed by the distal centriole. So let me say that again. The proximal centriole is what's going to form all the attachment structures to allow the head and the tail to be attached. Does the head and tail ever need to be permanently attached? Obviously not. Why? Because the tail needs to come off fairly easily, but not too easy. Okay? The distal centriole is going to make all of the microtubule structure of the tail itself. Okay? The mitochondrial sheath, which is basically a migration of the mitochondria during sperm cell formation to one area. Why are all the mitochondria located in this one area right here? Why are they not spread everywhere? How many of you, I'm going to be careful I ask this. I was going to say, how many of you own a whip? I would. You got dirty minds, not me. Okay? You know what a whip is, right?
Yes.
Now, how do we use a whip? If you know what you're doing with a whip, how do you use a whip? Where does the action of a whip come from? And what does a whip look like? Because keep this in mind, this is exactly how a sperm cell is structured and acts. If I've got a whip in my hand, tell me about the handle versus the tip. Handle is large diameter, tip is tiny diameter. Guess what? The diameter of the tail of the sperm is larger at the top of the tail than it is at the very bottom of the tail. Where does the whipping action come from? My wrist. Right here, right? Whip. Okay? Well, there's a lot of flexibility there, right? I can move it. That makes the whipping action. Guess what? There's a lot of flexibility right there at that attachment point. That's where it actually, the flexibility of the whipping action takes place. But where do we get the ATP to make the whipping action, or the flagellar movement? From the mitochondria. So we locate the mitochondria close to where we need to initiate that whipping action. If you look at a sperm cell under a microscope and watch the tail move, it actually whips. It's whipping. It's not spinning. I mean, they can spin, but that's an abnormality. But they're going to whip within a straight plane. They kind of whip back and forth, like you would have a whip in your hand. So keep that in mind as you think about it. The structure of a sperm tail is much like an actual whip, where at the beginning of the whipping action is thicker, going to a very thin tip or end of the tail, and the action takes place at one location in the case, the wrist here, like it would here, and the power needed, the ATP, to make the flagellar movement, because it takes a lot of ATP, is from this mitochondrial sheath. Now, here's where I want to attempt to do this, and I don't know, you don't make that. I just thought about this morning. Okay. So what we're going to do, we got plenty of time. I always have a hard time, I don't know if it's me or it's just a hard concept, to understand the microtubule structure of a sperm. Because it's not just one when I say tubule, think of it as a framework. You need framework to make the tail. But it's not that simple. It's not a couple of microtubules. It's a very distinctive, specific array of microtubules formed by the distal centriole. So here's what I'm going to do. To explain this, what we're going to do is we're going to go outside. Now, you're going to have to come in contact with your fellow classmates. Not inappropriate contact, but you might have to touch them. If you don't like to touch people, then you may have a problem. Okay? Nothing inappropriate. Keep your hands to yourself. Okay? No inappropriate touching. So what we're going to do is we're going to go out, and I'm going to explain to you, outside of the nice sunshine, the microtubule structure of a sperm cell using you. Okay? So let's go. You can leave your stuff and go.